Hello to our favorite first grade scientists, and welcome to the recorded lesson, Lesson 2, regarding light. Boys and girls, if you remember in our previous lesson, we discussed light and we explored how light can be blocked, reflected, or shine through various objects. And as we discussed light in our previous lesson, boys and girls, if you remember, there was a picture of a bedroom door, and we discussed that if the light outside the door was on and you decided that it was too bright and you couldn't fall asleep, you could close the door to block the light. And so that was one object that blocks light. We talked briefly about some objects that allow light to go through, either completely or partially. We talked about a plastic bag, a tissue, and we talked about how that light shines through those objects, either completely or partially. And then we talked about how light can bounce. Unlike a ball, a light can bounce or reflect off of objects, and we listened to the story of the morning birds and the mysterious lights. And at the end of the story, we found that the solution to the problem was the birds were actually seeing a reflection of light that was coming from a car. The headlights were the source, and bouncing off the shiny bird feeder. Now today, boys and girls, I would like you to take a look at this picture of the lighthouse, and I want you to notice that the light is shining into fog. You can see the beam of light very clearly because some of the light is actually reflecting off of water droplets that are in the air. Now, what I'd like you to do is to become a scientist when you're finished with this lesson and practice some different ways of using light. And the light source, the place that the light will be coming from, is a flashlight. So think about dimming the lights in your room and shining a flashlight on the wall. When you do that, you will see, if you look very closely at the beam of light, you'll actually be able to see dust particles in the air. Some of the light reflects off the dust and it shines back to your eyes. We are so used to light that we don't even think about it very much. In the daytime, the sun shines everything so brightly and it covers the earth with so many beams or rays of light. Rays of light are something like arrows that are fired from the sun. They move very fast, far too fast for us to measure it with our eyes alone. You can see a ray of light by looking at a partially closed curtain on a sunny day. So if the curtain is partially closed in the window and the light is brightly shining in, you can see that the light comes from the sun, which would be the source, and it lands on your living room floor as a beam. Some surfaces are able to bounce or reflect the light better than others. And an example of that, not much light will bounce off of a piece of construction paper because the surface is different. But if you think about a mirror can reflect almost the entire beam. Mirrors are great reflectors. A good reflector has a smooth surface, unlike that construction paper that it has a rough surface. Rough surfaces scatter the beams of light, and so they don't bounce back in just one direction. They kind of scatter in several different directions. When you have a surface that is really good reflector like a mirror, you can study the way that the light rays bounce off the surface. And if you take a look here, boys and girls, at this surface, this is a picture of a mirror. And this is our source, our light source, and it's coming down and it's hitting the mirror. And because the mirror is flat and has a smooth surface, it bounces directly off, and the light doesn't scatter, as you can see. It turns out that light rays bounce off a mirror in the exact opposite angle to the way that they came in. Let's discuss that a little bit further. Boys and girls, let's take a closer look at the way in which light bounces or reflects in different angles. Bill Nye the Science Guy has a great way of showing us the way light can reflect.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
This magnifying glass is making my eye look big. Now, why is that?
I don't know.
Please consider the following.
Okay.
When light enters something like air, water, glass, or plastic, it slows down a little. And when it slows down, it changes direction. See how one eye is lower than the other? See? Take a look at this. Here are 3 straight beams of light. When they go into the piece of plastic straight, they come out straight. But if the plastic is tilted, the beams of light get tilted. See, they change direction so that they come out this side offset. Now, what would happen if the piece of plastic didn't have straight sides, but had a curved side, like a magnifying glass? Well, the light would change direction, right? Because the surface of the plastic is curved, each beam of light enters the piece of plastic at a slightly different angle, and it changes direction a slightly different amount. Look, over here the beams of light come together at a single point. This is called the focal point. Now, what about the magnifying glass? Well, suppose your eye were over here, and light from the room were bouncing off of your eye and going through the piece of plastic this way. Well, then, the small area at this end would be spread out over a large area on this side. Your eye would be magnified. Ha! Thanks for joining me on Consider the Following.
Bill Nye the Science Guy.
Boys and girls, we know that light bounces off or reflects off of objects in angles. I would like you to take this opportunity to use a flashlight and a mirror, working with your learning coach, to experiment with the different angles in which light will bounce off or reflect from the mirror. Take notice of the way in which the angle you hold the flashlight or in which you hold the mirror, and how the light is reflected from the mirror. We know that mirrors are great reflectors because of their surface being smooth and shiny, and gives the light the opportunity to reflect completely without being changed. Can you guess what this is a picture of? Look carefully. Yes, it's a beautiful butterfly. Take a look at the right side of the red arrow. Now take a look at the left side of the red arrow. Boys and girls, when you have an object that is the same on both sides, we say it has a mirror image, or it is symmetrical. Some insects, butterflies for example, seem to have left sides and right sides that look the same. We know, boys and girls, that other objects do not look the same on both sides, and if they do not look the same on both sides, they are not symmetrical. Boys and girls, please be sure to work with your learning coach to experiment with different ways in which light bounces or reflects at different angles using a flashlight and a mirror. Also, be certain to check off on your online school Lesson 2, Unit 6 for Science.